Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Chapter 7, Lists in Python, Part 1 for the Class 11 students of Computer Science. In this video, we are going to discuss about introduction to lists, creating list, accessing list elements, indexing, traversing a list, aliasing, comparing lists, and practical implementation. So let's dive in and get started. Suppose you are planning to visit the nearby store to purchase your daily needs. What is the first thing you'd do? Yes, you'd probably write down a shopping list. Python also has a built-in data structure called list that's very similar to your shopping list. So let's go ahead and learn more about Python lists and see how they're analogous to our shopping list. A list is a collection of values or an ordered sequence of values or items. The items in a list can be of any type such as string, integers, float, objects, or even a list. The values that make up a list are called its elements. It's quite natural to write down items on a shopping list one below the other. For Python to recognize our list, we have to enclose all list items within square brackets, with the items separated by commas. Lists allow duplicate values as well. The element of the list can be accessed by its index. Did you notice that bread is the third item in the list, but is it indexed too? Well, this is because of zero indexing. In Python, index is essentially an offset from the beginning of the list. This is why the first element is at index 0, no offset, the second element is at index 1, and so on. In general, if the list has n elements, the last element is at index of n-1. Just the way that we can always modify our shopping list by reordering items, do things like replacing bread with our favorite chocolate, for example, we can do the same with Python lists. For this reason, lists are mutable. That is, values in the list can be modified, which means that Python will not create a new list when you make changes to an element of a list. Elements of the list need not be of the same type. List is a sequence data type like strings. We can learn one by one in detail. Let's see how to create a list. Lists can be created by putting comma-shaped values or items within square brackets. Square brackets indicate start and end of the list, consisting of elements separated by a comma. The syntax is list name equals square brackets. This construct is termed as a list display construct. Square brackets contain the set of values or elements constituting the list with a blank or no values, or we can say an empty list. The items in a list can be of any type such as string, integers, float, objects, or even a list. Let's see an example. Shopping underscore list equals open square brackets, apples, pens, bread, notepad, brushes, paint, close square brackets. In this example, we have a list of shopping list having 6 items, apples, pens, bread, notepad, brushes, and paint, separated by commas and enclosed in square brackets. Let's see some examples of creating different types of lists. Example 1. This line creates a list called list1 that contains integers. The numbers 10, 20, 30, 40, and 50 are elements of the list, printed and displayed on the console. Example 2. This line creates a list called list2 that contains strings. The letters A, E, I, O, and U are elements of the list, printed and displayed on the console. Example 3. This line creates a list called list3 that contains elements of different data types. The string Python, the integer 650, the float 27.4, the integer -680, the Boolean value true, and the Boolean value false are elements of the list, printed and displayed on the console. Example 4. This line creates an empty list called list4 with no elements. Since list4 is empty, it will display square brackets in the console. Example 5. This line creates a list called list5 that contains elements, including another list. The integers 2, 4, 6, and 8 are elements of list 5, and the list 3, 5 is nested inside list 5 as an element, printed and displayed on the console. You can check the output displayed on the console. Remember, lists are enclosed in square brackets, and hence the output here are all enclosed within square brackets. The list method in Python takes sequence types and converts a given record or tuple or string into list. We can create a list from an existing sequence using this built-in function list function. Let's see some example. Example 1. Creating a list from an existing sequence. List1 equals list function creates an empty list using the built-in list function. The list function with no arguments creates an empty list. The empty list is assigned to the variable list1. Since list1 is empty, it will display empty square brackets in the console. You can check the output in the console. Example 2. Creating a list from a sequence, string. This code creates a list called list2 from a sequence, in this case, a string. The string animation is passed as an argument to the list function, which converts each character of the string into individual elements of the list. The resulting list is assigned to the variable list2. Finally, it prints the contents of list2. When executed, it will display animation in the console. Each character of the string becomes a separate element in the list. You can check the output in the console. Example 3. Creating a list through user input using list method. In this code, list of input of enter the values prompts the user to enter values and converts the input into a list. The input function is used to receive user input, which is then passed as an argument to the list function. The list function converts the input string into a list, where each character becomes an individual element. The resulting list is assigned to the variable list3. Then finally, it line prints the contents of list3. You can check the output in the console. Here, enter the values, we have entered hello world. So the output displayed is that each character of the string hello world becomes a separate element in the list along with spaces. Here, let's learn how to create a list from an existing list. You can create a new list from an already existing list. Let's see some examples. Example 1. This code creates a list called list1 with elements 10, 20, 30, 40, 50. The second line, list2 equals list1 of colon, creates a copy of list1 by using the slice operator colon. The slice operator with no start or end indices creates a new list that contains all the elements from the original list. The resulting list is assigned to the variable list2. Finally, the contents of list2. When executed, it will display 10, 20, 30, 40, 50 in the console. Since list2 is a copy of list1, it contains the same elements. Any modifications made to list2 will not affect list1, and vice versa. Example 2. This code creates a list called list1 with elements 10, 20, 30, 40, 50. In the second line, list2 equals list1 of 1 colon 4, creates a new list list2 by using the slice operator 1 colon 4 on list1. The slice operator selects a portion of the list from the index 1, inclusive, to the index 4, exclusive. It extracts elements at indices 1, 2, and 3 from list 1 and creates a new list with those elements. The resulting list is assigned to the variable list2. Finally, it prints the contents of list2. When executed, it will display 20, 30, 40 in the console. The elements in list2 are the values that were selected by the slice operator from list1. Example 3. This code creates a list called list1 with elements 10, 20, 30, 40, 50. In the second line, list2 equals list1 assigns list1 to list2. However, instead of creating a new list, list2 now refers to the same list object as list1. This means that both list1 and list2 point to the same memory location where the list is stored. Finally, it prints the contents of list2. Since list2 is referencing the same list as list1, it will display 10, 20, 30, 40, 50 in the console. Now, let's learn about accessing list elements indexing. Lists consists of any collection of items which are stored according to the index. Like strings, any items in a list can be accessed by using the slice operator, square brackets, by specifying the index value. List indices start from 0 and go to the length -1. The list values can be a positive or negative integer value or an expression which evaluates to an integer value. You can access the elements from a list either moving from left to right, positive indexing, or from right to left, known as the negative indexing. Now look at this picture, which shows the positive and negative indices in a list. Positive index move from left to right, which starts from 0 and go to the length -1. Negative index move from right to left, which starts from -1, -2, and so on. Each given element, 10, 20, 30 up to 100, can be accessed through their indexes enclosed inside square brackets. Let's see some examples. Example 1. In this code, a list named list1 is defined with 10 elements, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. The print function is used to display the entire list on the console. You can check the output displayed as 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 in square brackets as it is a list. Example 2. This line of code accesses the first element of the list using the index 0. In Python, indexing starts from 0, so the element at index 0 is 10. You can check the above picture for reference. Therefore, when this code is executed, it will output 10 as shown in the console. Example 3. This line of code accesses the sixth element of the list using the index 5. The element at index 5 is 60, which is displayed as output. Example 4. Here, the negative index -4 is used to access the fourth element from the end of the list. In this case, the fourth element from the end is 70. You can check the above picture for reference. Thus, the output will be 70 displayed on the console. Example 5. In this line, the negative index -8 is used to access the eighth element from the end of the list. The eighth element from the end is 30. You can check the above picture for reference. Thus, the output will be 30, displayed on the console. Example 6. The code attempts to access the element at index 12, which is beyond the range of valid indices for this list. Since the list only has 10 elements, it will raise an index error exception when executed. It's important to remember that the valid indices for a list with n elements range from 0 to n-1. Accessing indices outside this range will result in an error. Let's see another example. Example 1. In this code, a list named list1 is defined with the elements s, t, o, r, a, g, e. The print function is used to display the entire list on the console. When executed, it will output as STORAG east with square brackets as it is a list. Example 2. This line accesses the fourth element of the list using the index 3. Since indexing starts from 0, the fourth element corresponds to the letter R. Therefore, when this code is executed, it will output R. You can check the picture for reference. Example 3. Here, the negative index -6 is used to access the sixth element from the end of the list. The sixth element from the end corresponds to the letter T. Thus, the output will be T. You can check the above picture for reference. Example 4. The code attempts to access the element at index 10, but the list only contains 7 elements. Since the index is out of range, it will raise an indexer exception when executed. It's important to note that the valid indices for a list with n elements range from 0 to n-1. Trying to access indices outside this range will result in an error. Let's learn about traversing a list. It's quite common to read through our shopping list to check if we've purchased all that we need. This is called traversing through the list. Traversing a list means accessing each element of a list. This can be done by using either for or while looping statement. Let's see the 3 ways how traversing can be done. First way is to use an in operator inside for loop. Example 1. In the first line, a list named list1 is defined with the elements C, O, M, P, U, T, E, R. Each element represents a character. In the second line, we use for loop. This for loop iterates over each element in list1 and assigns it to the variable I for each iteration. In the first iteration, variable I will be assigned the first element, that is, C, then the second element, O, and in this way each letter is accessed and displayed on the console. Each element is displayed on a new line till all the elements are traversed and displayed. Here, in operator using for loop iterates each element of a list in sequence. Example 2. Write a Python program to find the sum of all elements in a list. In line 1, a list named list1 is defined with 5 elements, 10, 20, 30, 40, and 50. In the second line, a variable named sum is also initialized to 0. In the third line, the for loop iterates over each element in list1. On each iteration, the value of I represents the current element. In line 4, the statement sum equals sum plus I adds the value of I to the sum variable, effectively accumulating the sum of all elements in list1. Finally, the print function to display the elements in list1 and the calculated sum. The sum of the list 10, 20, 30, 40, and 50 is 150. You can check the output in the console. The second way to traverse a list is to use range function. It checks for the given set of values mentioned as argument to the range function. This function can be used for accessing individual elements of a list, using indexes of elements only, along with the len method which gives length of the list and specifies how many times for loop will iterate. Let's see an example. Example 1. Write a Python program to count the total number of elements in a list. Now, look at the code. In line 1, a list named list1 is defined with the elements S, Y, S, T, E, M. In line 2, the len function is then used to calculate the total number of elements, or characters, in list1, and the result is stored in the variable n. In line 3, the for loop iterates over the range of numbers from 0 to n-1. On each iteration, the value of I represents the current index. In line 4, the print function is used to display the character at index I in list1. By iterating through the indices, each character is printed on a separate line, followed by the total number of characters, which is 6 in this case. The third way to traverse a list is to use while loop. The list elements or items in Python can also be iterated or accessed using a while loop. Firstly, the len function is used to determine the length of the list, then the while loop starts from index 0 and is iterated through the list items by referring to their indexes. Unlike a for loop, it is a must to increase the index by 1 after each iteration. Let's see an example. Accessing the elements of a list using while loop. Now, look at the Python code. In line 1, a list named list1 is defined with 4 elements. In line 2, an integer variable named index is initialized with the value 0. In line 3, the while loop iterates as long as the value of index is less than the length of list1. The condition index less than len of list1 ensures that the loop runs until all elements in list1 are processed. Within the loop, print of list1 of index is executed to display the element at the current index position in list1. After printing, index is incremented by 1 using index plus equals 1 to move to the next index for the next iteration. The loop continues until the condition index less than len of list1 becomes false, which happens when index reaches the length of list1. Here, length of list1 is 4. Each element in list1 will be printed on a new line, in the order they appear in the list. The while loop iterates over the indices of the list, printing the corresponding elements until it reaches the end. The output displayed, each element on a new line are AI, computer science, data science and information technology. You can check the output on the console. An alias is a second name for a piece of data. In Python, aliasing happens whenever one variable's value is assigned to another variable, because variables are just names that store references to values. Let's see an example. Let us create a list named fruits containing names of 5 fruits as string types. Fruits equals apple, mango, grapes, strawberry, and banana. The elements of fruits list in memory are represented according to their index values. Now look at the first picture. Since the list index always starts with 0, so apple is stored at index value 0, mango at index 1, grapes at index 2, strawberry at index 3 and banana at index 4. Now we will assign it to create a temporary list of the already created list, fruits, by giving the statement as temporary equals fruits. Now look at picture 2. Now, we have 2 lists having the same set of values. In other words, temporary is an alias, alternate, name for fruits list as assignment with an equal to operator does not make a copy, instead makes both these lists referring to the same location. We can modify the contents of these lines by referring to its individual index value. Look at these examples. In line 1, a list named fruits is created containing names of 5 fruits as string types. Fruits equals apple, mango, grapes, strawberry, and banana, and it is printed. You can see the output displayed in a list as apple, mango, grapes, strawberry, and banana. Now look at the next line. Here, we are assigning it to create a temporary list of the already created list, fruits, by giving the statement as temporary equals fruits. Now, temporary list is an alias for the list fruits. The next line says that index value 0 of temporary list holds the string peach. So, when printed, now, look at the second output, it displays as peach, mango, grapes, strawberry, and banana. Again, when fruits list is printed, the output would be, now look at the third output, peach, mango, grapes, strawberry, and banana, as both these lists, fruits and temporary lists, are referring to the same location. Thus modifications made in the temporary list are reflected in the fruits original list as well, since the same list is having 2 different names. So, we can say that changes with one alias get reflected in the other alias. The lists can be modified and represented with 2 values at one index position. It can also be represented in 2-dimensional manner. Now, look at the Python code. In line 1, the fruits code variable is a tuple containing nested lists. Each nested list represents a fruit and its code. Each nested list consists of 2 elements, the fruit name, a string, and the code, an integer. In the second line of the Python code, to access and print the second element of the fruits code list, you can use indexing with the number 1, since indexing starts from 0 in Python. Look at the first picture above. See the red marking. Indexing starts from 0. So, the output for fruit code of index 1 displays list containing string mango and code 55, which I have marked in light blue oval shape. In the third line of the Python code, to print the fruit name and its code separately, you can access the individual elements of the tuple using indexing. Now, look at the second picture. See the blue marking. The fruit name is the first element, index 0, of the tuple, and the code is the second element, index 1, of the tuple. So fruit code index 1 of index 0 is mango. I have marked in red oval shape, and fruit code index 1 of index 1 is 55, which I have marked in green oval shape. So the output displayed is mango and 55 printed separately. You can check the output on the console. Python allows us to compare two lists. Each element is individually compared in lexicographical or alphabetical or dictionary order. We can apply all the relational operators greater than, less than, double equal to, not equal to, and so on, to compare two lists if they are of comparable types, otherwise Python flashes an error. Let's see an example. In line 1, two lists L1 and L2 are given with values 10, 20, 30. In the second line, list L1 is compared with list L2. Both are equal and hence displayed true. But see the next example, list L3, which is a nested list. Here when L1 is compared to list L3, it's not equal and returns false. The second statement evaluates to false because L3 is a nested list and L1 is a simple list. Thus, on comparison, it generates false because both lists are different. Next, we will see how Python compares two lists by checking element by element comparison. If the corresponding elements are equal, it goes on to the next element and so on, until it finds the element that differs. Now, look at the tabular column below. Example 1. On comparing the first element, it yields true, as the first element 1 is less than 4, it generates true and hence the output becomes true. Example 2. On comparing the first element, it yields true, but on comparing the second element 2 is less than 5, it generates true and hence the output becomes true. Example 3. On comparing the first and second elements, it yields true, but on comparing the third element 3 is greater than 0, it generates true and hence the output becomes true. Example 4. On comparing the first, second, and third elements, it yields true, but on comparing the fourth element 4, which is not less than 2, it generates false and hence the output becomes false. Therefore, for comparing two lists, Python internally compares individual elements of two lists, applying all the comparison rules. Let's see some examples. 5 lists L1, L2, L3, L4 and L5 are displayed with values of different data type. Now come to line 6. Print of L1 equal to L2. This comparison checks if the elements in both lists L1 and L2 are exactly the same. In this case, L1 contains the elements 10, 20, and L2 also contains the elements 10, 20. Since the elements are the same, the comparison returns true. Now, come to the next line 7, print of L1 equal to L3. This comparison also checks if the elements in both lists L1 and L3 are the same. However, in this case, L3 contains the elements 10, 20, which are strings, enclosed in quotation marks, whereas L1 contains the elements 10, 20, which are integers. Since the types are different, the comparison returns false. Now, come to line 8, print of L1 greater than L2. The comparison greater than checks if one list is greater than another based on lexicographical order. In this case, L1 and L2 have the same elements, 10, 20. Since they are identical, the comparison returns false because neither list is greater than the other. Now, come to line 9, print of L4 greater than L1. Similar to the previous comparison, greater than checks if one list is greater than another. L4 contains the elements 10, 0, 20.0, while L1 contains 10, 20. The comparison is performed element-wise. The first elements are equal, 10 equal to 10, but the second element differs, 0 versus 20. In this case, 0 is less than 20, so the comparison returns false. Now come to line 10. Print of L4 equal to L1. This comparison checks if the elements in L4 and L1 are the same. However, the elements in the two lists differ. L4 contains 10, 0, 20.0, whereas L1 contains 10, 20. Since the elements are not the same, the comparison returns false. Now come to line 11, print of L1 less than L5. The comparison less than checks if one list is less than another based on lexicographical order. L1 contains 10, 20, while L5 contains 10, 20, 30. The comparison is performed element-wise. The first two elements are the same, 10 equal to 10 and 20 equal to 20, but there is an additional element, 30, in L5. Since L1 is shorter than L5, the comparison returns true because L1 is considered less than L5 in lexicographical order. Let's see another example. Write a Python program to find at least one common element amongst the two inputted lists. Now look at the Python code. Line 1 and line 2. The code starts by defining two lists, L1 and L2, which contain some integer values. Line 3 and line 4. The first print statement simply displays the elements in L1, while the second print statement displays the elements in L2. Line 5. The code then enters a nested loop structure with the first loop iterating over each element x in L1, and the second loop iterating over each element y in L2. Line 6 and line 7 inside the nested loops, an if statement checks if x is equal to y, line 8. If they are equal, it means a common element has been found between the two lists, so it executes the print statement that displays the common element. Now, check the output. The elements in list 1 are 150, 200, 250, 300. The elements in list 2 are 175, 275, 300, 375. Now the common element in both lists is 300. Thanks for watching. Watch the upcoming videos. Chapter 7, Lists in Python, Part 2. Operations on lists, concatenation, replication or repetition, membership testing, indexing, slicing, nested lists, copying lists and practical implementation. You can check the link in the description box below.